Students, now in our next type of questions, we are having the powers of the trigonometric terms. So I have written 3 questions over here. Y is equal to sine square x into cos cube x. Then y is equal to sine raised to 5x into cos cube x. And cos square x into sine cube x. All the 3 questions have an exact same procedure of the solution. So I'm going to solve the second question over here because there you can see that the powers are a little bit higher, isn't it? So I'm going to solve the second question, but remember that all the 3 questions are simply going to make use of the half angle formula of sine 2x. Now you remember that sine 2x is given to us as sine x into cos x. So I'll be using this particular formula extensively in solving all of the 3 questions. So as I said, I'm going to take the second question. So let's begin with the second question. Observe carefully, what do we have there? We have y is equal to, my first term is sine raised to 5x. So I write here sine raised to 5x into cos cube x. Now, how do I proceed with the solution of this type of questions? Now, students, always remember that there are 2 terms which are present over here and both the terms are having a power. Now, we know that there is nth derivative available for y is equal to sine ax plus b and y is equal to cos ax plus b, isn't it? The nth derivative is available for power 1 of both sine as well as cos, isn't it? That means the formula cannot be used if I get any power of sine and cos. The power has to be strictly 1. Further, the nth derivative cannot be applied for product of 2 or more terms, isn't it? There should be a plus or minus sign in between the 2 terms. Then I can definitely get the nth derivative by using the nth order formula. So here I can see that there are the product of the 2 terms as well as the 2 terms are having a power. That means there is no way I can proceed with the application of the formula directly over here. I need to first of all simplify the terms to power 1 and the product should be changed into positive negative sign. So let's see how it can be done. It's a very simple task. Now students, see, observe what carefully what I'm going to do here. I have sine raised to 5x into cos cube x. So I'm going to first of all maintain the power same. So how can I do it? Obviously raised to 5 can be brought down to raised to 3, isn't it? Raised to 3 cannot be brought up to raised to 5. That's a difficult task. So on the other hand, what I can do is I can reduce the power 5 to power 3. So my next step can be looking like this: sine square x into sine cube x into cos cube x, isn't it? I have brought the power 5 to power 3. Now you can see that there are 2 terms which are having the same power. We know a into b whole to the power m is a raised to m into b raised to m. The power gets distributed with the 2 terms if there is a product of the 2 terms. So this is sine cube x into cos cube x. It can definitely be written as sine x into cos x, the whole cube. So I get y is equal to sine square x into sine x cos x, the whole cube. Now I know that the formula for sine 2x is 2 into sine x cos x, isn't it? So I will need a 2 over here inside the bracket whose power is given to me as 3. So I'll be writing the next step as sine square x. Let's put the bracket and then inside the bracket I get 1 by 2 into 2 sine x cos x, the whole cube. Now students, you know that this 2 sine x cos x, the formula is going to be sine 2x, and this 1 by 2, its cube is going to become 1 by 8, and every term is in multiplication. The product is present over here. So I can simply write the first term as 1 by 8. Then there is sine square x, isn't it? And this 2 sine x cos x has become sine 2x and the cube of it. So I get sine cube 2x, isn't it? So now you can see that the power 5 and cube has now reduced to square and cube, and the angle has changed. There is sine x and then there is sine cube 2x. Now the next step is going to be changing this sine cube and sine square again to lower powers. How can that be done? So observe carefully. Look at this sine cube 2x. Now here again I'm going to tell you some very important formulas with respect to the cubes of sine and cos. Students, do you remember that sine 3x. Sine 3x has what formula? Sine 3x is given to us as 3 sine x minus 4 sine cube x. So if you observe from here, I can get the value of sine cube x. Now this is a very important formula. Students, always try to recall this formula. So from here, if I want to get that sine cube x term, this minus 4 sine cube x, it is present on the right. Let's bring it on the left. It becomes positive. That is 4 into sine cube x. I'm going to get rid of that 4 also later on. Now this term has been transferred on the left. This term sine 3x is going to be transferred on the right. So I get 4 sine cube x. Or let's remove the 4 also. I'm going to divide with respect to 4, isn't it? The entire equation will get divided with 4. So I get 4 sine cube x. So I write sine cube x, and there 4 is going to be go in the denominator. So there is 3 sine x, and this term sine 3x goes on the right. It becomes minus of sine 3x, minus of sine 3x, and this entire thing is going to get divided with 4, isn't it? That 4 sine cube x, 4 was present over there. It has to be adjusted. So the 4 which was in multiplication goes on the right, goes into the division part. This was the formula for sine 3x. Likewise, don't you also remember that there is a formula available for cos 3x, even though I'm not going to make use of the formula of cos 3x in this question, but you should be aware of that formula also. So cos 3x, if you know the terms, terms interchange, the numbers interchange, you get 4 cos cube x minus of 3 cos x. So from here, can you get the value of cos cube x? So here I can say cos cube x is going to be that minus 3 cos x. Now you need to send the minus 3 cos x on the other side, because you already have 4 cos cube x to the positive sign. It need not be shifted anywhere. Do not change the position of 4 cos cube x, because it is already positive. So I just need to send the minus 3 cos x on the left. It becomes positive. So I get 3 cos x, the positive term, plus cos 3x. And it was with 4. The cos cube x was with 4. So that 4 is going to come in the denominator. So both the formula, students, are very, very, very important. Now observe carefully the arrangement of the angles. You have sine cube x. So you get 3 sine x and then sine 3 times of x. So arrangement of angles should always be noted over there. So observe now in our term. What do we have? In our term, we have sine cube 2x. Sine cube in place of x, you have 2x, isn't it? So you need to replace that to x. Also, students, do you remember another half angle formulas? So you know that this y equal to sine x plus b and cos x plus b, both of them have the nth derivatives. I'm going to write the half angle formulas. Observe carefully. Even sine 2x equal to 2 sine x cos x is also a half angle formula. So half angle formulas, if you recall, there is 1 plus cos 2x. You must be recalling that 1 plus cos 2x, the formula is 2 cos square x, and 1 minus cos 2x, the formula is 2 sine square x, isn't it? 1 plus cos 2x and 1 minus cos 2x. These are half angle formulas. Now observe carefully. Let's come back over here. I have the first term as sine square x. I can see there is sine square x, but it is present with the 2. So let's not worry about the 2. It's a constant term. I can anyway bring it, isn't it? And then you have this sine cube 2x. You can see there is sine cube x formula available. This formula of sine cube x can definitely be made use for sine cube 2x also. The angle is going to change. So now let's get the values over here. I have this 1 upon 8, isn't it? This sine square x needs a 2. So let's bring a 2. So I can write 1 upon 2 into 2 and the sine square x, isn't it? And then you have this sine cube 2x. So initially let's write sine cube 2x, and in the next step I'm going to change it to the formula. So now tell me, what is 2 sine square x? What happens to 2 into 8? It becomes 16. So I write 1 by 16. The formula for 2 sine square x is 1 minus cos 2x. So I write here 1 minus cos 2x, and the formula for sine cube 2x, be very careful over there. In place of x, you can see there is a 2x. So all x will be replaced with 2x. So I get sine cube 2x as 3 sine 2x, isn't it? That x is changed with 2x. So you get 3 sine 2x minus sine 3 times of x. So 3 times of 2x, you get sine 6x. You need to be very careful with this kind of formula. Sine cube 2x, observe carefully. X is replaced with 2x. So go here and you start replacing every x with 2x. You get 3 sine 2x. That's my first term. You get sine 3 times of 2x. That is going to become sine 6x. And then this entire thing needs to be divided with what? This entire thing also needs to be divided with 4. So here I'm going to get whole divided by 4. Now obviously the 4 and the 16 will multiply. You get 1 upon 64. 1 upon 64. And students, can you also multiply the terms inside the bracket? Let's open the bracket. So you get 1 into 3 sine 2x. So 1 into 3 sine 2x, obviously it is 3 sine 2x. That's 1 into 3 sine 2x. Then 1 multiplies with minus of sine 6x. It is going to become minus of sine 6x. That's my product of 1 with this entire bracket, isn't it? So 1 multiplies with anything, you get the same thing back. Now the next term, you need to be very careful. There is minus cos 2x into 3 sine 2x. So I'll be getting minus of 3 sine 2x into cos 2x, isn't it? I'm rearranging the terms as sine 2x into cos 2x because I know there is a formula available for sine 2x, which is 2 sine x into cos x. The angles are getting half, isn't it? So 2x becomes x, 4x will become 2x, isn't it? So you need to be very attentive with the angles over there. So the product was cos 2x into 3 sine 2x. 3 is written at the beginning, then you write sine 2x, then you write cos 2x. Minus and minus becomes plus, isn't it? The next term is going to be positive. Minus and minus becomes plus. Cos 2x into sine 6x. Now you remember, whenever there is a product of two trigonometric terms, you should always write the first term with the largest angle, isn't it? Whichever angle is greater, that angle, that trigonometric ratio should be always written at the beginning. So I'm going to write sine 6x at the beginning, and then I'll write cos 2x. So plus sine 6x into cos 2x. So I'll write it on the next step. Plus sine 6x into cos 2x, and you close your bracket. Now you can observe the first term is 3 sine 2x. 3 is a constant. Let's not worry about the constant terms whenever we are talking about derivatives, because the constants will always move outside the derivative. So I am not worried about 3, isn't it? So I am more worried about sine 2x. Do you have the formula for sine 2x? You know that sine of 2x looks like sine of ax plus b. So I have the nth derivative available. Then there is a negative sign, sine 6x, again the same way, isn't it? Sine of ax plus b. This time a is 6 and b is 0. So there is no worry about the very first two terms. I have the direct formula available for both the terms. But now when I go to the next term, the third term, there is a product of sine and cos. So this term I need to think about, as well as I need to think about the last term also. It is sine of 6x into cos of 2x. So again, you need to multiply and divide by 2 over there to transform it into a defactorization formula. You can also make use of the defactorization formula for the previous term, but then it is a direct formula, so always make use of the formula directly if it is available to us. So students, my next step is going to look like what? So I'm going to write y is equal to, outside the bracket I have 64, isn't it? 1 upon 64. Then the next term is 3 sine 2x. It will remain untouched. Let's not do anything to that term. Let's not disturb it. So that's 3 sine 2x. I write here 3 sine 2x, then minus of sine 6x. Let's keep this term also as it is, minus of sine 6x. Now be very careful with the next term. I don't need this 3, isn't it? This 3 will not help me with the formula. I need a 2. So let's write this minus 3 as it is. Minus 3 as it is, and let's bring what I need. I need a 2. So I bring 2 and 2 in the numerator and denominator. Multiply and divide by 2. So that's 3 by 2 and 2 sine 2x cos 2x. 2 sine 2x cos 2x, and finally terms the sine 6x and cos 2x needs to be arranged. Again you need to multiply and divide by 2. So I write here the sign is positive over here, so I write plus, and I'm going to bring the 1 by 2, isn't it? I need to bring the 2. So let's multiply and divide by 2. So I get 1 by 2 into 2, and what the term that you have here is sine 6x into sine 6x into cos 2x. Now students, I am sure that you are already aware with the defactorization formula. We have already seen the defactorization formulas, and you very well know what is going to happen to this 2 sine 2x into cos 2x. Look at the angle. Angles play a very important part. This formula is now 2 sine 2x cos 2x. 2 sine, here you have 2x, so this angle is going to change to 4x. Sine 4x it is going to become. So I am going to write my next step as 1 upon 64. Let's write a bracket over here. 3 sine 2x minus of sine 6x, and students minus 3 by 2. What are you going to tell me for 2 sine 2x into cos 2x? It is simply going to become sine 4x. So I write minus 3 by 2 sine 4x, and be very careful with the next terms now. So I write a 1 by 2, then I put a bracket because I know there are multiple terms going to come for 2 sine A cos B. You know the formula. 2 sine A cos B is sine A plus B plus sine A minus B. So I'll be getting sine A plus B. So that's 6x plus 2x. You get 8x plus sine A minus B. You get 6x and minus 2x. That becomes 4x. And you close the bracket and you close one outer bracket, isn't it? Now, this 1 by 2 can be multiplied inside. You can see all the terms. Observe all the terms very carefully. There are two terms which are sine 4x. So, it is an obvious step that both the terms of sine 4x must be brought together. So, for that, I need to multiply this 1 by 2 inside the bracket. So, can you now observe that 1 by 2 sine 8x is going to be the term of highest angle, and it is also with a positive sign. So, let's write the first term as 1 by 2 sine 8x. Now, it does not matter over here whether you rearrange the terms or not. It is not going to make any difference, but since I can see that the highest angle is 8x, I'm going to write 8x first. So I write 1 upon 64, then a bracket. So my first term is now going to be half is going to get multiplied inside the bracket. So this 1 by 2 multiplies with both the terms present inside the bracket. So my first term, students, 1 by 2 into sine 8x, isn't it? 1 by 2 into sine 8x. Now the next term is going to be 1 by 2 sine 4x. And I have minus 3 by 2 sine 4x. So obviously sine 4x is common. Now, before the sine 4x, is it okay to write sine 6x? Because that is the greatest angle, isn't it? After 8x, the next greatest angle is 6x. So let's first write minus of sine 6x. Now, the sine 4x and the sine 4x, both the terms are going to come together. Minus 3 by 2 and plus 1 by 2. So minus 3 by 2 plus 1 by 2. Both the terms have the same denominator 2. So minus 3 and plus 1. That gives me minus 2 upon 2 gives me minus 1. So minus 3 by 2 and plus 1 by 2 will give me minus 1. So I write minus 1 and I write sine 4x, isn't it? So that is sine 8x, sine 6x, sine 4x, and finally the last term is going to be 3 sine 2x. So let's write the last term plus 3 sine 2x. Plus 3 sine 2x, and you should be closing your bracket. So did you observe the term that was given with power highest 5 and cube? It was a very large power, power 5 and power 3. This power has been now reduced to power 1, isn't it? All the terms are reduced to power 1. And what has happened to the angles, students? The angles have also changed: 8x, 6x, 4x and 2x. So you can easily understand that a term, the trigonometric term of higher power, can be reduced to power 1. Obviously the angles are going to change. So this particular expression and this expression are one and the same, but now it is definitely possible for us to make use of the formulas of nth order derivatives. So students, now I'm going to differentiate n times, isn't it? Let's differentiate n times. So I'm going to get yn now. What happens to 1 by 64? It does not disturb the derivative, isn't it? Nothing happens. A constant term will always come outside the derivative. So 1 upon 64 has been taken outside the derivative. You'll be getting 1 upon 2. That's again a constant term for the first term. 1 upon 2 sine 8x. Now you know there is u plus v plus w plus s, you can say. So you need to simply differentiate every single term individually, because there is a plus and minus sign in between. So you take the first term, you see that there is a constant present with the first term. So this constant simply goes outside the derivative. So 1 by 2 goes outside, and the derivative of sine 8x, the nth derivative of sine 8x is going to be 8 raised to n sine of n pi by 2 plus 8x. That's my nth derivative of the first term. Then minus the next term is sine 6x. So that's 6 raised to n sine of n pi by 2 plus 6x. Then minus of what's the next term? You have sine 4x. So that's 4 raised to n into sine of n pi by 2 plus 4x, and finally you have the constant 3, and sine 2x is going to be 2 raised to n sine of n pi by 2 plus 2x, and you close your bracket. So students, have you observed again? Getting the nth derivative is quite simple, isn't it? If you know the formulas, if you have the standard forms, once you get a standard forms, it is very easy to make use of the formula for nth order derivative. What is a real challenge is to get that term, get that standard form, and for that you need to make use of lot of trigonometry. So students, observe carefully in all these steps that I have done over here. Extensive use of the trigonometric formulas has been done. So it is very important that you need to be very strong with your trigonometric formulas, as and when they are required into the steps. I am writing them down over here, but it needs to be a mandatory task that you need to do is you need to learn the trigonometric formulas. So students, that was all about this particular type where the powers of sine and cos were involved. Now let's move on with the next type of questions.